Hey boys and girls, welcome back. We are going to talk about graphing logarithms today. And graphing logarithms is going to be our last lesson for the unit. How exciting! You're done with the unit. You've learned everything about exponentials and logs that you need to know for Algebra 2. Anyway, um yeah, today's gonna be a lot like yesterday. You're gonna look at some graphs. We're gonna identify some key features of them, and then we're gonna see how can we use graphing utilities to make these graphs ourselves. So let's go ahead and talk about what the graph of a log even looks like. So let's compare it to the exponential graphs that we saw yesterday. For our exponential graphs, we had a horizontal asymptote where the graph kind of curved down but got really close to that invisible line but never quite crossed it. And it went both directions forever. So this exponential graph continues left forever, continues right forever, goes up forever. It has a y-intercept at 0, 1, as long as we don't do any shifts to it. And it has an asymptote at y equals 0. Okay. Logarithms and exponentials are inverses of each other. So the way we get a logarithmic graph is by doing an inverse to this graph. So we could take all these ordered pairs, 0, 1, and we just reverse the order. 1, 0, there's a point on our log graph. We could take this point right here, 1, 2, inverse it to 2, 1, 2, 1. There's another point on our log graph. And then we could repeat that process until we have the entire graph. What this means is that everything we know about exponential graphs will be reversed for logarithmic graphs. Exponential graphs have a horizontal asymptote. Logarithmic graphs are going to have a vertical asymptote at y equals 0. Pardon me, x equals 0. I saw the y there. So the equation of a vertical line is always x equals a number. On your homework, it's going to ask you for the asymptote. You're going to have to write the equation of the asymptote. If you just put 6, it's going to mark that wrong. You have to put x equals 6 for it to be counted as correct. Likewise, this kind of immovable y-intercept, the constant or that point, right, that shows up on all exponential graphs as long as we don't shift them, will show up on all logarithmic graphs except it's inversed. So instead of being at 0, 1, it's at 1, 0 right here. So any logarithm, regardless of base, will always have this point right here at 1, 0. Okay, so let's go look at some log graphs and see if we can pick out the key features on them. So here's a log graph. The first thing I want to say, though, is that I don't really like that. What color is that? Maybe this color? This stops here. Log graphs actually keep going forever down. So that'll be the first thing we talk about. For exponential graphs, our domain was all real numbers, and then our range was from the asymptote to infinity. Because the log graph is the inverse of this, these are going to switch for logs. So for all logarithms, the range is all real numbers, and our domain will be the one that is dependent on our asymptote. Likewise, for the asymptote, we're looking for an invisible vertical line that seems to follow. So this one seems to follow an invisible vertical line like that. So looks like it's right about there. So the equation of this line is x equals 0. So that's our asymptote. All logs will have this invisible vertical line. Sometimes students are a little confused why this is x equals when this line goes up and down like the y-axis. The asymptotes are defined by like which axis they cross. So this one is going perpendicular to the x-axis, so it's going to cross the x-axis. Like if I had one here, it crosses the x-axis but not the y-axis. That's kind of how we want to think about why it's an x. The other way we could think about it is if we look at all the points on this line, like this point, this point, this point. This is 0, 5, 0, 10, 0, -5. Do you see how all the x's are the same? All the x's equal 0. So that's why vertical lines are x equals and not y equals. It's because all the x values of the ordered pairs on that line will be the same. All right, for our intercepts, this graph looks like it's crossing right here at 1, 2, 3, 0. So let's put that. So 3, 0 is our x-intercept. And our y-intercept, it doesn't have one. This graph gets really close to that y-axis, but because there's an asymptote on it, it can't ever touch. That's kind of the definition of an asymptote. It gets really close to the asymptote, but it never touches it. Okay. For our domain is always going to be from the asymptote value. So x equals 0. So it's going to start at 0 and go to infinity. I don't like saying always. Let me give you a disclaimer. In this class, it will be from 0 to infinity, or from the asymptote to infinity. There are ways to reflect this. You could make a graph that goes like that, but it won't show up in this class. Okay. For our end behavior, notice x doesn't go to infinity anymore. That's because this graph doesn't keep going left forever. Instead, it curves and follows a line. X goes to this number. This end behavior is telling you what that asymptote value is. So as x goes to 0, as we get really close to this asymptote, what direction is our graph going? Well, it's going down. Down is negative on the y-axis, so this will go to negative infinity. As x goes to infinity, as we go to the right forever, this will continue increasing forever, and it will go to positive infinity. So there's all the key information about this log graph. Let's take a look at this one. All right, the first thing I'm going to do again is extend my log graph the way it's supposed to be. Okay. And I shouldn't cross that line, but it's kind of hard for me to draw a straight line. All right. And then it looks like our asymptote is right here. All right. So let's talk about this asymptote. This asymptote, first of all, it's here in the end behavior. X equals 1. The way we can get the asymptote from our equation of our log graph is by looking at the h value. Remember, h is always backwards from what it should be. We have log some base of x minus h plus k. The number inside the logarithm with the x will tell us where the asymptote goes, but we need to change the sign. Here it's -1, here it's +1. So we need to change the sign from the equation to get our asymptote. All right, looking for intercepts, this graph crosses at 1, 2, 0. And because of this invisible boundary, our graph will never get over to the y-axis to cross it. So no y-intercept. For our domain goes from whatever value the asymptote is to infinity. Remember, domain and range should always go from small to big. Infinity is definitely bigger than 1, so it should always be the second number in the domain. Range, every single logarithm has the same range, and it's all real numbers. And then our end behavior, as x goes to 1, it's going down. So it would go to negative infinity. And then as x goes to infinity, this is going up to infinity. All right, let's do one more. Here, our log has just been flipped upside down. It's been reflected vertically, and that's because of this negative sign right in front. But we can still find all the same information. So our intercepts, it crosses the x-axis right there at -1, 0. And it crosses the y-axis now because this is going to shift our graph left too. So now we have a vertical asymptote right here. Because the asymptote is to the left of the y-axis, that means that it's okay for it to cross the y-axis now. So it's moved left, so now we can cross the y-axis right there. And we're at 0, -1. So there's our two asymptotes. This one is an not asymptotes, intercepts. This is our x-intercept, this is our y-intercept. The asymptote is that x equals the h value, change that sign to a -2. We can also see there's an invisible line here at -2 on the x-axis. All right. Our domain goes from the value of the asymptote, -2 to infinity. And then our range goes from -infinity to infinity, which is the same thing as all real numbers, just an interval notation, so you can see it a different way. Our end behavior, x goes to -2. If we look as it gets really close to this asymptote, now our graph is going up. So we're going to say it goes to positive infinity this time. And then as x goes to infinity, the right side of our graph is going down. So this would go to -infinity. All right. Let's talk about you graphing some of these because they're going to give you graphs and you have to look at them and match them. So let's talk about how you're going to do that. You're going to use an online graphing tool. What you're probably going to use is Desmos because it's built into your homework. But we don't really need to worry about this. This is that base change I talked to you guys about if your calculators don't have the button that lets you type in the number. So Desmos actually does. I tested out before this. So if you want y equals log base 2 of x plus 3, the way you would get this base is you're going to do log, then you have to do underscore, which is to get an underscore. Underscore, you do shift, and then you press the dash button. There's like a longer dash. It's an underscore. Underscores tell it to make a subscript. So you'll do underscore 2, and then it'll look like this little lower subscript, and it should look fine and work okay on Desmos. Okay. All right, so, I spoiled this a little bit. Okay, so we want to graph y equals log base 2 of x plus 3 plus 1. So you type this into Desmos. To get this little 2, again, it's log underscore and then type 2, and it should give you the little subscript. Make sure you put the parentheses on this, x plus 3. Make sure the plus 1 is outside the parentheses. And then let's just check this to make sure it kind of looks right to us. This is telling us where our vertical asymptote should go. So it's x equals, remember to change the sign, -3. And we can see we have a vertical line here at -3. I added this blue line separately so that we could actually visually see it, but it won't show up on yours. Next, we have this plus 1. So normally, your log will cross the x-axis 1 to the right of your asymptote, and we can see that doesn't happen. That's because it's been moved up 1. So here's 1. That point is right there. Those are really the two key features you want to be looking for on your graph. You want to make sure that your asymptote is in the correct spot, And that x-intercept is in the right spot unless, of course, you have a vertical shift. Okay, so there's our first graph. Here's our second one. Again, to get this 3, you're going to do log underscore 3. And then we want to make sure our asymptote's in the correct spot. So this minus 4 tells us our asymptote is at x equals positive 4 because we changed the sign. If we look here at positive 4, we can see the asymptote that I added is right there. And then normally it'll be crossing the x-axis 1 to the right of the asymptote, but it's been shifted down 2. So if we go 1, 2, we can see there's that point. So there we go. Make sure you are graphing these in Desmos so that you can look at them and try and match them. And then if you have any questions or comments, concerns, need help with anything like finding or writing your domain and range in interval notation or anything, please let me know. I would love to help. Otherwise, have a wonderful rest of your day. Make sure you like and subscribe. Make sure you do your homework. Make sure you tell your parents how grateful you are. Actually, maybe if you have crappy parents. Hopefully you don't have crappy parents. If you have good parents, tell them how grateful you are. Have a great day.